Yeah, normal.
Okay. Maddie.
Anthony's not nicest, but she was actually nice yesterday.
There you go.
That's amazing. She was like, stop. Quiet. Instead of just calling me Luke, she went like, Luke.
I love that.
No, she says Luke like Luke.
Okay. So, I want you guys to have time to start or even finish your homework. So, hopefully, I had some examples after this, but if you guys were good with that part, I won't necessarily go over them. So, for this, x is -2. I'm writing this like f of -2 equals 1/2 times -2 plus 3, yes? Are we all in agreement? Okay, you plug it in for x. Okay, so what's my ordered pair solution? Anastasia? -2, 2. So x is always -2, so -2 should be here, y should be 2. And my order pair for this one over here, Eric.
-2, -27.
Right, -2, -27. So this is f of -2 equals 3 times -2 cubed plus 2 times -2 plus 1. Which is a lot of stuff, but if you do order of operations, you should get -27. Does anybody need me to actually go through that? No? Okay. If you're going to do this in your calculator, what I have up here, your calculator, if you put -3 squared, will tell you that it's -9. It's a random example. Because it does 3 squared times -1, which is -9. If you do negatives with exponents in your calculator, you need parentheses. So that's just for future reference. All right, number 3, ordered pair solution. Maddie? No. Y is -3, so everyone should have y -3 for y. You can call it plus 7.
Oh, I did it wrong.
Okay, Andy? Yes, -15. So this, what is this actually equal to? F of x equals what? Y. Right, this is y, this is y. So -3 equals 1/3 x minus 2. That's a two-step equation. Solve for x plus 2. You get -15. Lucy?
I asked Miss Anthony this yesterday, but I didn't get a really clear answer. Why don't you just say y rather than f of x?
Because you will have different equations. Well, first off, it's just notation, but it's telling you the name of the function, f, and it's telling you what variable it's defined in. So this is in x. If you want multiple, later on you'll need multiple different equations. So it's nice to have b of x, g of x, h of x, so you can just differentiate how many you have. And then you could even do like g of I, where it's 2i squared plus 2 if you want to. This just tells you what variable is in the equation.
So why don't they just say g equals g of I?
Just tells you what actually being used. The function of I. Yeah.
I think it's just complicated.
Isn't it like x?
It just tells you what variable they're using. What is this defined, and it's using x. So that's why the x is there. It's the function of x. That actually makes sense.
I prefer just y or one variable.
It makes more sense when you get further into mathematics, because you'll need multiple functions, and they might be defined in different things.
Yeah, I'm just so used to y.
Yeah. It's just a simple, different way to put it. Sure. Almost. Yeah. Right, -1/4. So, in the video we had you cross this out. -3 equals 2 over x plus 5. Subtract 5 first. Then you can use cross products, or you can multiply times x and multiply over. Does anybody need me to go over that one further? What is this called? What can you remember? Well, yeah, the inverse function. And what is this called? something? Yeah, keep it. Good job. Okay, so in your packet, in your note packet, did you guys do 3 and 4 on page 14 in class?
Well, I did. Oh yeah, I did 3.
Okay, everybody do 4, and then on page 15, everybody do 4. So just do 1. Do 4 on page 14. And on page 15, if you already did, that's fine. And on page 15, do number 4. Number 4 on page 14, number 4 on page 15. Are you going to tell me that solution? Oh, were you asking me to share? Okay, go ahead. Yes, but you should be able to get it done in class. Okay. This is page 14 in the notes. In the top. Page 14 in the notes.
Maybe you should circle it.
It's bolded and it's underlined and it's in a different color. So I feel like
Maybe
that's
you should shade it or highlight it. But I feel like drawing attention to it, you know?
okay, whatever. Okay, so you can tell me the order pair, the solution. Anything else?
Negative 7.5, negative 6. Wrong.
That is page 15.
Oh my goodness. Negative 3 more.
Negative 3, negative 1. Negative 3, negative 1. You write this as h of negative 3 equals 1/3 times negative 3. Okay, and then, is everybody okay? Eric? Nathan has already told me this second one. So negative 7.5, negative 6.
Oh.
Eric?
Negative 15.
Okay, thumbs up, thumbs down. So that's just really. Okay, you guys are going to breeze through this lesson today. So down your homework, we're going to check it, and then we'll do the lesson today. You'll love. Okay, Kevin, what's your order pairs for number 1?
Negative 3, negative 41.
Yes, and then the number 2.
2, 34.
Yes, Maddie, number 2.
Negative 28, 2, negative 6.
Yes, number 3, you don't have your stuff. Brianna. Number 3. Yeah. Will, number 4.
Negative 3, negative 9.75, and 2.
Wonderful. Lucy, 5. Yeah. Alina, 5.
Negative 3, 13.2, 3, negative
8.8.
Oh,
Oh, I forgot to review that one. Eric, 6.
negative 3, comma 15, and 2, comma 8.9.
The second one is right. Marissa, what did you get for the first negative 3?
Negative 3, negative 2.
And then to 8.9. Number 7 is negative 3, negative 4.4, 2, negative 0.4. 8 is negative 3, 9, 2, comma, 0.6 repeated or 2/3. 9 is negative 3, negative 7.125. The equivalent fraction is negative 57 over 8. And 2, negative 5.25. 10 is negative 3, 14.5 into 2. 11 is negative 3, negative 15.6, and 2, 5.4. And then, you can't really see, 12 is negative 3, negative 20.5, and 2, 10. Any questions on that first one?
No, I was just wondering.
Of course. Yeah.
Not all of it, no. I made some of it.
Okay. What's number 13?
5, comma 8.
Yes. GG 14.
5,
Yes. 539. Andy 16. Or or 15. Anastasia, 16.
Negative 214.
Yes. 17, Kyle. Yes. And Nathan S, 18.
I think I did. I don't really know.
Okay, Eric, 18.
5, 30.
Yeah. And 19 is negative 33, 20 is 1082, 21 is negative 518, and 22 is 1031.9. So questions on any of those? That is where you subbed in a number for y or f of x, n of x, or it's all correct. Alrighty then. Get out your note packet. We are going to page 16 on your combinations. I should be able to breeze right through this. I thought you were going to make something. You'll probably be able to finish it in class. Every other class has finished it in class, so you should be okay, linear combinations. Page 16. Okay, so we found ordered pair solutions in the last section, which you guys thought was really easy. Another word for those ordered pairs is linear combinations. It's just another word that is relabeling what we already know. So we are determining if a given linear pair or ordered pair is a solution to an equation. If it is, it's called a linear combination. So it's just what we've been really finding. So in the first part, you have a box. A linear combination is an ordered pair that is a solution to a given equation. So just like your homework, you found an ordered pair that if you had plugged it back into the equation that you had, it would have given you a true statement. That means it's a solution. It's a linear combination. It's just almost, it's like a vocab term almost. The ordered pair, so it's an ordered pair, x comma y. You know ordered pairs are always x comma y, the x value and then the y value. If you have a coordinate and it's a solution, it falls on the graph line of the equation. So if I had y equals 2x plus 2, and I had this graph, and I know a solution is 0, 2. That point should be on this graph. If I know a solution is 2, 6, that point will be on the line. So any point on the line is a solution. A line is a graph of the solutions. Basically all the same. So example, is 2, 7 a solution to the equation y equals 2x plus 3? This is x, this is y. You don't have to put those down if you don't want to. You substitute x in for the x coordinate in for x, y coordinate in for y. You've done this before. So 7 equals 2 times 2 plus 3. Order of operations, 7 equals 4 plus 3, 7 equals 7. That's true. So your answer to these questions is yes or no. Is it a solution? Yes. You plug it in, you check it. Just like how you would check your answers whenever we're doing systems. Another thing you can do, put a graph. I want everyone to put a graph right next to this example. And graph y equals 2x plus 3. So make your own graph 2x plus 3. So you start at 0, 3, go up 2 over 1, up 2 over 1. If it is a solution, it should be on the line. So 2, 7, over 2, up 7, 1, 2, 3, 4, 5, 6, 7. It's on the line, it's a solution. Another way to check it. So if you were using your calculators, you could graph a line and hit table. You guys know table. All of those listed are linear combinations. They're ordered pairs that are on the line. All graphing is. So I want you to do 1, 2, 3, and 4 by yourself. Is it a linear combination? In other words, is it a solution?
This one goes.
Yeah.
3 and 4 is
You don't need to make a graph. That was just for the example. You can just say yes or no. But make sure you show some work at least. Okay, number 1, yes or no, and what was your final equal something? Andy? Yeah, yes, 4 equals 4. Number 2, Aaron.
No, 8 does not equal 13.
Yes, 8 does not equal 13. Number 3, Anastasia. Yes, 6 equals 6. And the last one, number 4, well, no. And you don't have your something equals something. No. Anything else?
Negative 3 does not equal 6.
Right. Negative 3 does not equal 6. Okay. Do last one. Next page. You have 2 equations. I'm going to label that one 1, this one 2. Not equations, 2 ordered pairs. Yeah. It could be both, it could be none, it could be one or the other. Okay, number 1 is 2, negative 14. What do I have? Let's see.
I think that's yes.
Yes. Because what equals what?
Negative 14.
Negative 14 equals negative 14. And number 2, Gigi. Right. Yes, negative 4 equals negative 4. That's the whole entire lesson. Except we're going to do 2 word problems that are really easy.
Yeah. That's okay. Just as long as there's no questions like that on the test.
Yeah. There won't be. Or we'll tell you. Okay, word problem. So add this in at the bottom. There's tons of space. Wonderful space right here that you can add this in. Okay, these are easy. You will be fine. Do you have room? The rectangle shown below has a perimeter of 52 inches. Write an equation describing the possible values of x and y. So you have to remember what perimeter is. And what should my equation be? Andy? 2x plus 2y equals 52. And then we need 3 linear combinations for the equation. So what are some possible things? Vicky.
Y could be 18, X could be 16. Is that possible?
What did you say it was? 8, 16? 18,
No.
16.
16. No, wait. I'm sorry. I need to redo that.
You said 18, 16, which is where?
Yeah.
Oh.
It's 18 or 8 or 18 and 16. I think it's 18 and 8.
18 and 18 is 36, 36 plus 16. So it's, oh no, it's 2.
Yeah, it would have
Never
to
mind.
be
Yeah, you're right. It's 8.
8. I got it. That's all.
I was doing 16. Yeah. 9. 13 and 13. Anything else?
8 and 18.
8 and 18. That's clever. Okay, you get the idea, yes? Linear combination is another way to say solution, yes? Next one, your beagle is allowed to eat 800 calories of food each day. You buy canned food containing 40 calories per ounce, dry food containing 100 calories per ounce. Write an equation describing the possible values of x and y. First we have to say, what do you want x and y to be? Gigi? X words. We have to define what x and y is. Because they're asking about x and y, but they didn't tell us about x. In what? It's not going to be calories.
I don't know. Day.
No. Maddie?
I'm not really sure.
Canned food, okay. So one is going to be canned food, but it's the ounces of canned food. Right? Because it's 40 per 1 ounce, so ounces of canned food. And what should my other one be by process of elimination? It'd be right, the ounces of dry food.
So the dog can have only 8 ounces of dry food.
Of dry? Yes.
That's terrible.
Okay. So how would I write this equation? Here.
40 plus 100y equals 8.
Right, and Loopy just gave me 1, 0, 8, 5, 6, 5, 6, yes. Brianna? Yeah, 10, 4. So you get the idea. Linear combinations just mean solutions. See? Wasn't today a good day?
No.
Yeah. You thought it was going to be back because it was Friday the 13th, but it wasn't. Okay. Okay, you have plenty of time to finish this in class, okay? 1 through 8. And then 33 in the homework packet. 1 through 33. Or not 1 through 3. 1 through 8, 11, 12, and 15.
I don't even have a page 33.
It's page 33 in your homework packet, and you definitely have it.
31.
It's in the back. For a different packet.
In the back?
In the, no, I mean in the back of the but a different packet. Okay, so if you look, 1 through 8, you have 2 ordered pairs that you have to see if they're a solution or not. Label the first one A, the second one B. That's what I did. Show something. And I just put very end product. So if you look at A, I have 9 minus 4 equals 5.
So only one of them can be the right.
No. State whether each ordered pair of numbers is a solution of a given equation. That means you could have 2 that are, 2 that aren't. You could have 1 that is and 1 isn't. Doesn't matter. There aren't any restrictions. But just make sure you're labeling